Hello and welcome to Data Viz with Class. I'm Caleb Class and I'm a data science professor. This channel is about using data visualization to explore and explain the world. Most of all, it's about sharing the joy of data visualization, maybe having a little fun. In this first video, I'm going to take you, someone who maybe hasn't ever tried computer programming before, and I'm going to give you the basic building blocks to make any dang graph you want, because R and ggplot2 lets you do that. R and RStudio are completely free, and if you need help installing it, or if you'd like to run RStudio in the cloud, check the links in the description. Let's get started. So now that we have RStudio ready to go, let's quickly go through a few of the windows or panels that appear. It might look like this when you first open it up. Down to the right, you have your files where you can find and load data. If you're using an installed RStudio, it'll put you in some folder on your computer. Let's go ahead, click this little yellow folder button, create a new folder. You can call it Data Viz, whatever you want. And we will save everything for this in this folder. So to navigate, you can go up, you can go down, you can click in your folders, just like you would in a normal window. Plots will show you all of the data visualizations you make, and help will let you look at R's help files, which can be super useful when you're just starting out or when you're trying something new. Up on the top, there are a few other useful windows that we'll look at a little later as we go along. You might see one or two panels on the left. Let's start with this one called the console. This lets you type R code and see the results. So let's stop for a bit of terminology. RStudio is this whole big application we're using. It's got all these different panels in it. R is the name of the programming language, or the coding language, that we're trying to use to accomplish our analysis. So kind of like how English is one language that you might type into the application Microsoft Word, R is the main language that we will use in the RStudio application. The R code can be as simple as a quick calculation. 5 plus 3 is 8. 12 squared times 10 is 1440, or it can get much more complicated. And you can see when we type in our code, let's go to this history panel up on the top, it saves what we've done. So I could double click and I could run it again if I wanted to, just using enter. Now when we're putting together more complicated code, it's a lot nicer to have all of it saved in one file so that you could open it back up again later, see what you did, or make changes if you need to. So let's open up a new script using this little button with the plus sign on it. So new R script. Now we get an additional panel. It says untitled. Now we can type our code here, just like in the console. We note that if we just hit enter, it just goes to the next line. It doesn't actually run it. If we want to run it, we hit Control Enter, and now we can see it down at the bottom. Go ahead and change it just so you can see it's something new. 5 plus 4, Control Enter, the answer is 9. Let's go ahead and save this, just like you would a Word document. You could go to File, Save As, or you can click this little blue picture on the top. If you know what this is, you're old. I went ahead and called it First Script. Now it's down in our Files window, so if I want to just click it, open back up later, I can do that. Okay, so now we can type our code up here. We can save it for later. One other thing we can do is string pieces of code together by saving results as objects. We do that by giving the object a name, whatever name you want. Could even call it whatever if you want. We make this little arrow using the less than symbol and a dash, and then whatever the code we're running will go on the right of that. So 5 plus 3, we save the result as whatever. If I then type whatever, hit Control Enter, we can see that that has been saved as just the number 8. We could also run other calculations using that object. So now we're stringing what we did before. Say multiply that by 5, we can see that it's 40. Okay, but we can do much more complicated things than that, and we will. So back to the windows, if we go over to the right panel, we can see that our environment, which used to be empty, now has an object named whatever. It is just a value, it's just a number, it's just the number 8. Not so exciting, but another thing we can do is load a whole big data table as an object, or maybe we've done an analysis, we've saved the result as an object. Those will also show up over here. We could click on them, we could actually see the whole data table. Now let's try to make our first graph. I think ggplot2 can make some of the best graphs out there. This is an example of an R library or an R package, which provides you with a lot more options of things to do in R. So we will go down to the console. I will type install.packages and then tidyverse in quotes. And we're doing tidyverse because this is a larger package that includes ggplot2 as well as a lot of other useful stuff. So we are getting a lot of installation done with just this one step. And I do it down in the console because we only need to install it once. Now in our script, I'm going to go type library tidyverse. You don't actually need to use quotes in this one. I'm going to hit Control Enter. So when we use the library function, we have to spell it right, but what that is doing is it's kind of actually opening the software. So just like you have software on your computer, you've got to install it, but then you'll also open it. You install it once, but then you open it whenever you need to use it. So whenever we need to use the tidyverse or ggplot, we're going to use this library function. So now let's analyze some data. In general, we'll be loading in a data set from an Excel file, maybe connecting to a public data set on the internet. Let's start simple. R includes a lot of free data sets for us. They're already loaded, not always that exciting, but they're just sitting there for us, so let's use one. So if I type mt cars, you can see a big data set shows up. I can type !mt cars, that's how to get a help file. Then a help file shows up to the right. You can see it is a data set based on Motor Trend car road tests from the 70s. Okay, so this shows us what all the columns mean. We're not going to look at a lot of them, but if you were to do a real analysis of this data, you'd want to know what all those columns meant. Most of how we interact with R will be through functions, which is a whole big chunk of code that someone else already wrote for you to perform a task. So let's say you want to calculate the average of all the MPG in this data set. So let's find MPG. There you go, it's the first column. We could go up here, we could type 21 plus 21 plus 22.8, etc. We could divide the whole thing by however many cars there are. That'd take too long, that kind of defeats the whole purpose of R. Instead, we can just use the mean function. So mean mt cars, that's the data set, $, MPG is the column. So let's go through this. The mean function says we want to calculate the average. Mt cars is the data set we're using. We then put a $, and then MPG is the column of the data set we're using. So when I hit Control Enter, we see that in this set of cars, they get an average of about 20 miles a gallon. A few other common functions we could use the summary function instead of mean. So that gives you a variety of summary statistics, including the mean, but also the median, max, and min. And then finally, you could use the view function, and you can see the whole data set. So you could scroll through. Potentially, you could even search it, and you could also sort various columns from high to low. Toyota Corolla, good car, 34 miles a gallon. Cadillac Fleetwood at 10. So let's close that up. Now we're going to make that graph. To make the graph using ggplot, we want to start with the ggplot function. So whenever we're using a function, it's the name of the function. We put parentheses. Let's hit Control Enter. So you have made your first graph. Not really a graph, but it's a space that could theoretically have a graph in it. To actually make a graph, we need to tell ggplot what data we're using, what to do with it. I want to use the mt cars data frame, so I'm going to type data equals mt cars. And then maybe my question is, do heavier cars get better or worse gas mileage? You might be able to guess the answer to that question, but let's analyze the data and see if our instinct is true. We need to say what type of graph to make. So I'm going to go outside the parentheses. I'm going to type a plus, and then I'm going to hit enter to give myself another line. And I'm going to add a geom_point function. So this is one example of a geom function. There are tons more. We'll explore them in the future. Now we hit this. Still not enough. We get an error because we are missing aesthetics. All right, so we need to tell ggplot how we will use the data in our data frame to make a graph. Let's use the aesthetics function to do that. So that is AES. And then what we need to do is say which columns to use for the x-axis and the y-axis. So if I'm going to plot mileage versus weight, let's put x equals WT for weight and y equals MPG for mileage. So for each car, the x-axis is the weight of the car, the y-axis is the miles per gallon. Control Enter. There you go. It's our first graph. So x-axis weight, y-axis miles per gallon. In just a few minutes, we have gone from nothing to completing our first exploratory data analysis. And we can see that, as expected, heavier cars got worse gas mileage. So we made something, but let's make it better. You can also use the aesthetics function to change the color, the size, or the shape of your points based on the data. Let's say we also want to look at horsepower, or the HP column in this data set. We want to ask, do more powerful cars also get better or worse gas mileage? Let's do this by sizing our points based on horsepower. So more powerful cars will have bigger dots. So we will use the size aesthetic, and we will set this to HP or horsepower. Control Enter, and there we see it. In general, we see that the heavier cars also have high horsepower and generally get low gas mileage. The lighter cars generally have lower horsepower, although you see a few that have more power. Maybe they have a little oomph, and maybe they get a little bit worse gas mileage than other light cars. We're not going to say anything for sure based on this. If we wanted to do some real statistical analysis, we could figure that out. Instead, let's make the graph look bigger. I am going to add a theme function. There are lots of options. They let you quickly change the overall format of your graph without really any effort. So I'm going to add plus. I'm going to hit enter, give a line return, and I think theme_classic is nice. Very clean, very classic as the name suggests. So now we get rid of the background. Looks pretty good. Let's also make our axis titles a bit more informative. So instead of MPG and weight or WT, let's actually spell them out so the user understands it a little better. So let's say xlab parentheses weight. It needs to be in quotes. So this is weight in thousands of pounds plus ylab miles per gallon in quotes. Then let's give our whole thing a title using ggtitle. And we will say heavy cars get worse gas mileage. All right, now it's a little more informative. And finally, let's change the color of the points. Since we're not coloring the points based on the data, let's say you just want to make them all aquamarine because you're a weirdo. We will type that down in the geom function. So not in the aesthetics function, just in the geom function, we'll say color equals aquamarine in quotes. Okay, not sure about that. You could also put a hex code with a pound sign. So that lets you use any old color you want. Say you work at Netflix, here's Netflix red, bring back nailed it. There you go, that one looks decent. And finally, say you want to add a bit of a gradient. You want to color the points just left to right based on the weight. Color equals weight. I'm going to go ahead and close this parentheses too. And then you can see we get a nice little color gradient going from left to right. We could adjust the colors themselves if we wanted to using a thing called a scale function. We'll save that for a different video. I do want to get rid of this new color legend that came up because that is kind of in the way and not really necessary. And I will do that using guides, color equals none in quotes. And there you go. Maybe you've never used R before in your life, you've never programmed at all, and in not too much time, you went from the basics to making a pretty nice scatter plot. So let's take a look at this one more time and see how each element of our graph is set up using ggplot. We need to tell ggplot what data set we're using, so the name of our data object, or the data frame, as we call it in R. We need to tell it what type of graph to make using a geom function. We need to tell it how to use the data to make the graph with the AES function, and there are tons of other things we can do to change the formatting or add other elements. If you gain a little practice and learn the logic behind R and ggplot, the possibilities are nearly endless. You'll make some amazing graphs. I hope you enjoyed this tutorial. In future episodes, we'll try to answer some of your questions about the world using data visualization. So I would love for you to ask questions in the comments, and I'll address some of them in future videos live and on the fly.